The following presentation is based on one of the over 600 idea sheets created by teachers for RAFT, Resource Area for Teaching. RAFT idea sheets are a free resource for teachers and available at any RAFT location. They're also available online at raftsac.org. RAFT idea sheets reference various content and grade level standards and are all aligned to address California content standards ranging from grades pre-K through 12. Standards in your state may vary, but RAFT lessons are easily adaptable and often applicable to additional subject areas and grade levels. If you've downloaded the RAFT idea sheet online, you'll find your sheet includes the following sections to guide you through the activity: topics, materials list. This activity can be used to teach, assembly, to do and notice, the science behind the activity, and web resources. Terms in this activity. A spectroscope is a device for producing and observing a spectrum of light or other radiation. Diffraction grating. A diffraction grating is an optical device consisting of a surface with many parallel grooves in it that disperse a beam of light. Visible light spectrum. The visible spectrum is the portion of the electromagnetic spectrum that is visible to the human eye. This video is divided into multiple sections: an overview, what you're watching now, the actual demonstration of the lesson, including a complete materials list, and taking it further, showing some real-life applications for the concepts presented.
Do you remember the last time you saw a rainbow in the sky? Or how about one up close, playing in the backyard sprinklers on a sunny day? The colors you saw, a scientist would call the visible spectrum of light. When light enters a raindrop or a piece of glass called a prism, it's bent and broken up into the 7 colors: red, orange, yellow, green, blue, indigo, and violet. I'm David Traversi, and today we're going to build a RAFT kit called the Colors of Light. Let's build. This is a completed spectroscope that we'll be building right now. We're going to need a tube, some tools, a hole punch and scissors, some green sticky dots, some tape, and a special piece of plastic called a diffraction grating. This little plastic has thousands and thousands of tiny little lines etched into it, which allow the light to enter in one side and then break apart into the various colors on the other side. We'll start by punching a hole into the sticky dot. Right about the center. Works perfectly. Then we're going to need to cut a small piece of the diffraction grating. About 2 centimeters by 2 centimeters works well. That's about the size of your thumbnail. This piece right here will be applied to the back of the sticky dot. And so we want to take a moment to make sure that it's really stuck on there well so that you can use your spectroscope for a long time. I'm going to apply this dot to the top of the tube, again, right about in the center. And then I'm going to use the palm of my hand to try to bend all of the edges over and really secure it on tightly. You'll want a nice tight seal. If you're worried about it, you can take a piece of tape and attach it around the outside. There, that's perfect. For the other side, we have to create the slit for light to enter into. So we'll take another dot. I'm going to cut this one right down the middle. And to create the slit, we're going to apply the dot in 2 pieces. The first side, we'll stretch it over right in the middle, pull it tight, and mash it down. Make sure it sticks really good. For the second half, we're going to edge this right up to it and create a thin slit. Now you can vary the thickness of the slit, and everyone in your class will do it slightly differently, but don't worry, it's going to work just as well for everybody. You can trade them around and see how they're different. Pull it tight, bend it over, and there we have a nice slit that you could easily pass a nickel through. I'll take another piece of tape, wrap it around, And there you have it, a completed spectroscope. Light goes in the slit, comes out the diffraction grating into your eye. Now that we've built your spectroscope, it's time to use it. We're going to want to point this towards a light source in your classroom, with the diffraction grating end towards your eye and the slit to allow the light in, pointed up at one of the ceiling lights. The lights in your classroom might be fluorescent, which will show a bright burst of color. Now, if you have a different kind of light in the classroom, an incandescent bulb from the overhead projector or something, go ahead and point it at that too. You're going to see the same bright splash of color, but a slightly different pattern because the bulbs have different materials inside. In the upper grade levels, teachers will burn different metals from the periodic table, and you can identify what types of metals they are by the pattern produced by the spectroscope. Now we want to take it outside. Outside, there's lots of things to look at too. There's plenty of reflections from the sun, but you don't ever want to look through the spectroscope directly at the sun. When you go home, there's lots of things to look at there too. A television screen produces bright light, a computer monitor. If you can ask your parents to light the stove, the flames coming off the stove will show a distinct pattern of what's burning. If you take it outside to a campfire, you're going to want to look through your spectroscope at burning wood because that will produce a bright color that's different than anything else that you've seen. Your next fireworks show, you have to bring out the spectroscope because all of the burning elements inside fireworks will produce brilliant patterns for you to see. Your job is to notice how light is different wherever you look. And remember, there are lots of ideas on your RAF sheet for you to think about and discuss with your classmates.